Thanks everyone for taking the time. I'm Ehsan Tutuni, co-founder and CTO of Bodo. We are a new platform for processing big data, but with native Python APIs and HPC performance scaling at the same time. So orders of magnitude better performance and efficiency, we believe, using our new inferential compiler technology. So for this talk, I want to give you an overview of what Bodo is and how you can give it a try and how it works internally. Please feel free to ask questions. Looks like we are, kind of a nice small crowd. We can have an interactive discussion if necessary. So the problem today in the data world is that in enterprises and organizations, data scientists and data engineers write code in Python on their laptops, but some other team has to rewrite the code for scaling to production. So Python code is used for prototyping, but others write it for production, and it's extremely difficult. And this rewrite happens to things like Java, Scala, sometimes even C++, SQL, with technologies like Spark, Presto. And they go to production. Even when they go to production, their performance and scaling and efficiency is not HPC. So these systems have enormous inefficiencies, which leads to very high cost as well. So time to business value and developer productivity is low, and efficiency is low as well. But what we are offering is a new platform where the same Python code can be scaled to production, and the code doesn't change. The APIs are standard, NumPy, Pandas APIs, but the platform provides connectors. You need to load data from somewhere. Typically, large Parquet files are on S3 or large data on Snowflake, big tables, things like that. So Bodo supports that, automatically parallelize the code, optimize the code end-to-end, use the efficient primitives for analytics operators, integrations, and so on and so forth. So that's what Bodo provides. Here is an example code, which is actually from one of our partners, NASDAQ, a big exchange in the US. So they wanted to monitor latency of the transactions on the exchanges. So they have their order book data, kind of transaction data in Parquet files. They load it into a data frame, then filter the table based on a regular expression, choosing some sessions that they want to analyze, and then call describe, get statistics of the transaction latency. So very simple workload, but critical to what they do. What we did was just add Bodo.JIT decorator, which enables compilation, Bodo compilation for this code, and they ran it on a small cluster in their own environment. It was actually a Hadoop cluster. So just ran it with MPI, 224 cores, over 100x speed up, same code. They ran it on Google Cloud, Azure Virtual Machines to make sure it's portable, which is a big requirement for exchanges. So very simple code, Python, and it was much faster than their Spark version of the code and more capabilities than Spark, because in Spark, things like quantile, things that don't fit map-reduce pattern of Spark are not available, but Bodo can support them because we have a more general architecture. So at a high level, the program is written in open source APIs, Pandas, NumPy, anything else in Python and SQL, and the data can come from anywhere. Could be CSV or Parquet files on S3, ADLS, kind of cloud storage. It could be data warehouse like Snowflake. It could be Hadoop, and Bodo can run on any platform, from your local laptop to any cloud infrastructure, and you can integrate it with any other system out there, BI and visualization, right? To give you a sense of the kind of performance we are talking about, this is TPCx Big Bench results from one of our customers, our largest customer, which is a big tech company. And they want to use Bodo for ETL, data prep, kind of feature engineering in machine learning pipelines, these difficult big data processing tasks. So their data team tuned Spark as much as they could and created a large cluster, 125 AWS instances, large instances, 4,500 cores, 4,500 cores, and tuned Spark as much as they could, and just ran Bodo. So Bodo was 20 times faster on the exact same hardware, which means 95% cloud cost saving as well for this particular run. The data set was fairly large, 40,000, scale factor 40,000, which is roughly 40 terabytes for the whole data set, and the workload uses a subset of it. Okay, so ETL, data prep, feature engineering, these sort of things, Bodo is orders of magnitude faster than Spark. But going back to the root of the problem in this area, in computer science, this has been an open problem for decades. There is a gap between simplicity and performance in program. So you have high-level scripting code in Python that's very simple, but runs on a single core and doesn't scale, right? On the other end, high-performance computing environments here in US national labs and some big universities write very low-level MPI. MPI stands for Message Passing Interface and is the standard for high-performance computing on supercomputers, right? So they write low-level MPI, Fortran, C++ code that scales to hundreds of thousands of cores, extremely efficient, but not many people in the world can write this code. So this is a very large gap. And the solution would be a way to compile the high-level code to the HPC version so that anyone can write the high-level code. And that's exactly what we are doing here. So our inferential compiler is a new type of technology. In an ordinary compiler, you have, let's say, C++ code, and it's translated one-to-one into a binary you can run, assembly you can run, right? The compiler doesn't do too much the structure of the program. But our inferential compiler is able to understand the structure of the code and analyze the structure and operations at a very high level, and then transform the logic to a fully parallel version, not the sequential original code. So fully parallelize it and convert to a fully parallel native binary. We can run on any number of cores. So a fundamentally new type of compiler technology. So to compare Bodo's parallel architecture to others, what we are saying is Bodo uses true parallelism, as HPC experts would do. And these other systems for big data are not truly parallel. So with something like Spark or Dask or Ray, you rewrite your Python code in their new APIs that run on their library. They are library-based, right? A distributed library. And the code starts on a driver program on a single process. But when it goes to one of these API calls, the library breaks it up into tasks, goes across the cluster, and comes back. So it's like fan in, fan out. We call this waves of tiny tasks. And these tasks have enormous overheads and are extremely inefficient. And the program is not truly parallel because it's actually running on a single process, just breaking things off. With Bodo, the code is compiled to a native parallel binary with MPI and runs on bare metal. There is no runtime library breaking up tasks. There is no scheduler. There is no master driver. So all the cores, each core has a chunk of the data. All of the cores are actually running the program, and they communicate very efficiently until completion. There are no tasks, no overheads, and this is the scientifically correct way to do parallel computing, we believe, right? So there are two dimensions for these big data solutions that matter. One dimension is simplicity, about developer productivity and ease of use that turns into time to business value. The other dimension is performance, how fast and scalable it is. So we believe Bodo is far from other solutions like Dask, Spark in the space, and we provide simplicity and performance for the first time in this space. Okay. So based on this technology, we believe Python shouldn't be a prototype language. A lot of people, kind of business people, think production code has to be written in Python or Scala or C++. We think Python, given our technology, can be used for difficult data engineering problems in the enterprise, like ETL, data prep, feature engineering, these sort of things that people go to, things like Scala, Spark, they can be done in Python, and Python should be the default production language in the enterprise. Okay, so that's our goal. Now, to be able to work with a very large data sets, you need to be able to load data efficiently. That's a key requirement. Just the start of the program is loading data, whether it's loading a large Parquet data set or CSV data set or a table from a warehouse. That's the first step. So Bodo loads the data set into chunks in different processors and different cores automatically. And depends on the data type, has different algorithms to do it very efficiently. So let's look at one example of scalable I/O in this environment. Snowflake, a data warehouse like Snowflake is particularly challenging to work with because you submit a query, issue a query, and data has to come back. And there is a standard protocol, JDBC, ODBC, that's not particularly fast or parallel. Okay, so you would maybe all the cores submit a query, it would overwhelm the warehouse, 1,000 queries from 1,000 cores, and your program may fail. Even if it works, it's going to be very slow. So we worked with the Snowflake team, engineering team, and built this new solution, and they provided some features. They called it distributed fetch. So one processor says we want to read data, and Snowflake makes data available in a staging environment and provides batches to different processes, different cores. So you can actually divide the data very efficiently among cores. And the performance is kind of similar to reading Parquet files, which is very, very impressive. So it's as if the data is on S3. They are actually creating some sort of environment to load the data, and the data transfer happens in arrow format, which is very efficient. Right. So this is just one example of a connector to load large data sets, terabytes and petabytes of data efficient. Now, what is the limitation of Bodo? Not all Python programs are compilable. Okay, most of them are compilable, but not everything is compilable. For example, in Python, the left example, you could have variables that have different data types during execution time. This variable A could be a scalar 2 or could be a NumPy array, right? And you can check the type and do some operations based on the type. So these sort of things are not compilable because the compiler has to assign a data type to A and know whether it's a scalar or an array. That's a requirement. But generally, these are rare and can be refactored easily. The other kind of scenario is you can have function called objects dynamically created and called during runtime, and the compiler can't resolve the function call. This is very rare and should be avoided. This is not good programming practice. It has to be avoided for Bodo. The other possibility is data frame schema has to be known to the compiler. So in this example on the right, based on a flag, a data frame has a column of integers versus a column of strings. So the compiler doesn't know which one it is during compilation time and can't compile it. Again, these sort of things can always be refactored, and it's better to be avoided anyways. So there are a lot of cases in Python that are dynamic, and we are trying to kind of build technologies to handle them as much as possible, kind of automatically. But otherwise, you have to learn, kind of how this compiler works and avoid these sort of things, right? All right. So in this area, there are a lot of people and companies claiming that they will make Pandas fast. They will make Python and Pandas fast. And they typically don't show any evidence or just very simplistic benchmarks, just load a file or run a very unrealistic operation. So it's not clear who has the best solution and what are the use cases for each solution. So what we did was that we took open source TPC-H benchmarks. So TPC benchmarks have been developed over several decades by the database community for data processing workloads. And TPC-H and DS and these sort of things are for analytics type of thing. So everyone knows what these things are, but they are in SQL. So we took these benchmarks and converted them to Python and Pandas. So the program on the left, for example, is a SQL query, select some tables, it has a bunch of filters, a nested query, group by, sorting, and so on and so forth. But the Python one on the right is just standard Pandas, right? Group by, merge, and things like that. So we translated this, and this is all open source available to play with, and ran some benchmarks and compared to Spark, Dask, and Ray to show where Bodo is in terms of performance for this type of workloads, big data processing and analytics type of workload. So compared to Spark, we created a cluster on AWS with 16 large instances, 576 physical cores, and scale factor 1000, which is a terabyte of data. So here are a couple of the examples of runs. Spark is in tens or hundreds of seconds, but Bodo is in a few seconds. And Bodo is 23 times faster than Spark on average, up to 65 times, which is over 90% infrastructure savings, which is a large cost saving as well. So speed up and saving and simplicity of Python. Compared to Dask, Dask is just not able to process large data. Just impossible to do big data with Dask because it couldn't even load the terabyte data set. And we actually consulted with Dask experts. They validated what we did. And we switched to a smaller data set, 100 gigabytes. And even then, we were up to 500 times faster than Dask. So Dask is just a distributed scheduler, not really built for big data processing. So, 100 seconds in the middle one versus 0.2 seconds. It's just not even comparable. So we believe, Dask has a long way to go to be able to process large data. And Ray ran out of memory for whatever reason for a 10 gigabyte data set. We couldn't even get it to work with Modin for data processing. And they have big claims, just change a single line of code, but we couldn't get it to work. And that Ray is originally built for reinforcement learning applications. So it looks like they don't have data processing, so big data support yet. And even if these guys, Dask and Ray, build it, they are distributed schedulers, so they will look like Spark. They are not HPC solutions. So we believe Bodo is the right solution for big data processing. Okay. But I want to leave you with a real customer use case, a large retailer, international retailer. And the problem was they were using Spark for processing for their machine learning analytics data pipelines. And Spark was just too slow to do analytics in real time. So in this example, Spark was taking 1.1 hours for running the pipeline, and it was not practical to do things in real time. With Bodo, we did the same thing in 6 minutes. Okay, and the data set has 25 billion rows. It's not small, and it's 1.2 terabytes in compressed format on disk. So with the 16-node cluster, we got 12x better performance, which is translates to over 90% cost saving. Their Azure bills are $1 million a month. It's not small. So that's a big problem that they have in terms of cost that we resolve. So with that, I would like to go to a demo, but before I forget, we have a community edition that's free to use for your laptop, 8 cores. You can just install it from Conda. And we have a managed cloud service, free trial, and we have free trial licenses for on-premises clusters as well. Just please contact us, and we have a Slack channel for community participation. So with that, I want to show you some code. This is our cloud platform. It creates resources in your own account, right? So we can create clusters, attach notebooks to it, right? So I have this notebook. I will open it here. And I've created a cluster here, which is 4 workers of C5 4x large. So these instances are 8 cores each. So the cluster has 32 cores. So I have an example program here. This is, this is kind of, we are trying to show typical data processing. So I'm generating a 50 million point data set, so a data frame, 50 million rows with a single column with just some date columns. And it's about 380 megabytes, something simple, and dumping it into Parquet for processing now. So regular Python would take 30 minutes or 25 minutes, so I can't run it. It's just extremely slow. So the code is just an apply where assigns a code based on if it's the first 5 months of the year versus others. So very typical data transformation, and these user-defined functions are very slow in Python, right? But Bodo can make them very fast. If I run the same thing with Bodo, add the JIT decorator to the same function, Bodo can make these things very fast. So I will just run it right now. It takes a little bit to compile and initialize. This is the first time I'm running something on this notebook. I think my notebook is, yeah, it's running. So it took a few seconds, so from 1200 seconds to 5 seconds on a single core because of compilation of this program. And now I can run it on the full cluster with adding the PX, and it took 0.13 seconds, just extremely fast because it got parallelized on all the cores. So you can, for these programs, you can get orders of magnitude better performance. So with that, I would be happy to take any questions.